Alright guys, so today we're going to be going over missing angles. So basically what we're going to be doing today is using our trig ratios to be able to solve for an angle or our theta. So previously in the last lesson we just left it at like cosine theta equals 3/4 or something like that. But now what we're going to be doing is we're going to actually solve for that angle. So got a little bit of an exploration activity here. So what I want you guys to do is just take a second and figure out what the sine of 30 is for each of these. So what I mean by that is that the angle that we're going to be using as our reference angle is that 30-degree angle. So remember, sine is opposite over hypotenuse, so our opposite side would be 1. So this would be 1 over, and then our hypotenuse, assume these all have 90-degree angles. Our hypotenuse would be 2. So the sine of 30 for this first one would be 1/2. So real quick, for those next two, go ahead and pause the video and then figure out what sine of 30 is for B and C there real quick. So yeah, actually, go ahead. Do it. Hit pause. Pause. Okay. All right. So if you actually took that moment to be able to hit pause, figure this out, you should have seen that for B here, your sine of 30 would be 5/10, right? Which simplifies to 1/2. That's curious. Okay. On this next one, on C, we would have found that our sine of 30 is 25 over 50, which also simplifies down to 1/2. So the sine of 30 for each of these triangles is the same. And one thing we know about these triangles is that each of them have two angles that are the same, right? They have the 90-degree and then the 30. 90-degree and then the 30. So remember back to last unit that if we have triangles that have two angles the same, that means that the triangles are similar. And that's what we discussed in Unit 10. And so because each of these triangles are similar, we know all the side lengths are proportional. And this is why any trig ratio of the same angle will always be reduced to the same value. So sine of 30 for no matter how big the triangle is going to be reduced to 1/2. Cosine of whatever is always going to be the same value as long as the triangle has that same angle measure. So translation, sine, cosine, and tangent values of any angle are fixed values. So they're always going to be the same. Always, always, always. Okay? Why do we care? So since those trig ratios are a fixed value, we can now match the value, any trig ratio, to the angle that it comes from. So we can do this by using something we call inverse trig. So what does that mean? Is basically knowing that the trig ratio for any angle is a fixed value, we can solve for that angle. Okay? And so, because we can solve for that angle, we can use inverse trig, which is very similar to our inverse operations that we've been doing for a while now. Okay, so what I mean by that, Remember when we were like solving an equation and you had like, when we had like a squared plus, when we did the Pythagorean theorem and you got like 144 plus b squared equals 576, for example. So we had addition, so the opposite of addition was subtraction. When we solve equations, when we have multiplication, the opposite of multiplication, or the inverse of multiplication, is division. So we're going to have that same thing with each of our each of our trig functions. So what we're solving for in each of these trig functions is theta, or our missing angle, but we've kind of gotten used to calling it theta. You'll see down here in these other examples that we have theta, but then we also have like a question mark, or I'll have you guys define it as x. Okay, so when we started it off, we had sine, right? And sine was so, which was our opposite side divided by our hypotenuse. So the inverse of sine, we write that as sine to the -1, and we write that, and we say that the inverse sine of opposite over hypotenuse. So theta is equal to the inverse sine of opposite over hypotenuse. If we were to do this for cosine, cosine is c, or adjacent over hypotenuse. And we would write that the same, except now as cosine to the negative first. Or the inverse cosine, theta is equal to the inverse cosine of adjacent over hypotenuse. All right? And then what we have, you guys can probably guess it, we'd have the inverse tangent of opposite over adjacent. Ta-da! Okay, so unlike addition and subtraction, multiplication, division, so on, these inverses are not entirely intuitive. So what we have to do is we have to use our calculator. So you need to make sure you have a graphing calculator, scientific calculator. My calculators are out in class, so if you need to borrow one of mine, you can, but just make sure you are not guaranteed to have one of my calculators available during the test. So I would make sure you get your own. Okay, but let's look at a couple of these. So with A here, we got to look at what sides we have to figure out what trig ratio we're going to use. So we have our theta, we have our opposite side, and our adjacent, because it's next to our angle and not the hypotenuse. So since we got opposite and adjacent, that means we would use tangent. So we could say our tangent of theta, since we don't know what that is equal to 9 over 7.4. Okay, but as this problem says, it says indicated angle, which is our theta. So we got to use our inverse operation to be able to solve for that theta. So that means that our theta would be equal to the inverse tangent of 9 over 7.4. Okay? And then from there, that would be something that we just go ahead and plug into our calculator. But there's one big thing with this. We got to make sure our calculator is in the proper mode. So I'm going to show you an example of something that looks like a TI calculator, but you may have to Google it. If you're using one of my in-class calculators, just make sure that in the top it has a little D symbol, and you should be good. But you may have to Google how to get your calculator into what we call degree mode. So let me move this. So this might be something like what you see with the graphing with your TI calculator. So right next to the second button is this button called mode. So we hit mode, okay? And then it comes up with all of these different functions. Not going to be exactly like that, but on the graphing calculator, if you look at like the third line down, it has a choice between radian and degree. What you need to make sure is that it's in degree mode. So you would just arrow down over to degree, hit enter, and then if you clear out, you're in good shape. Okay? And then, so we would just have to type in what we had, which was the inverse tangent of 9 over 7.4. So we come here, the way we do the inverse tangent is you just go second, and then the tangent button, and you should get that where it says tangent to the negative first. And then you just type it in. So 9 divided by 7.4. Close your parentheses, hit enter, and you see we get 50.57219 some. In the problem, it says that we need to round to the nearest hundredth. So that means hundredth is our second decimal place, so we'd have theta is equal to, what was it again? 50.57. degrees. And that's our answer. We don't need to do anything else. That's our angle. Our angle theta is equal to that guy right there. Okay? Then we just repeat that same process. Again, remember rounding to the nearest hundredth. So we got to identify what size we have for this next one for B. We don't have our opposite, but we do have our adjacent and our hypotenuse. So with adjacent and hypotenuse, we would need to use, c. So our cosine of theta would equal 5 over 16. But we're solving for theta, so our theta would equal the inverse cosine of 5 over 16. And again, we just plug that into our calculator. So we come to our handy dandy calculator. Second cosine, 5 divided by 16, enter. We're rounding to the hundredths place, so we'd have 71.79 degrees. So theta would equal 71.79 degrees. Okay. One more, and then I will end this video, give you guys a chance to figure out do those other problems on your own, and then you can check the next video to be able to finish off the notes. Okay? So now we got our question mark. That's our indicated angle. We don't have our opposite, but we have our adjacent and our hypotenuse. So much like B there, we're going to be using the inverse cosine. So now I'm just going to skip a step. Since we're solving for our angle, our question mark is going to equal the inverse cosine of 20 over 24. We can simplify that, but remember from above, we saw that no matter what, if it's simplified or not, it's going to give us the same answer. So let's just leave it there. So we got the inverse cosine of 20 over 24. So we go to our calculator. Second cosine, I think it was 20. 20 over 24, 20 divided by 24, enter. We get 33.557, so we need to round that to 33.56 degrees. So our question mark on this one is going to equal 33.56 456 degrees. Okay? Okay, pumpkin? Alright, so now guys, I'm going to end this part of the video and now do D, E, and F on your by yourself, and then check the next video to see if you got it right.